Good afternoon, everyone. Welcome to Make the Future, Connecting Girls to Manufacturing, increasing the participation of females in advanced manufacturing pathways. This is our table talk number 6, designing interactive hands-on activities to attract more females into manufacturing. My name's Kathleen Fitzpatrick. I'm the NAEP Senior Program Manager, and I'll be talking to you today about this topic. Hopefully you'll find it interesting and inspiring and can be useful in the work that you're doing with students in manufacturing. The National Alliance for Partnerships and Equity Education Foundation, or NAEP, has been tasked to engage educators and recruiters in a network where they can learn and share best practices to increase participation in advanced manufacturing pathways. This project is intended to increase the capacity of educators in targeted North American communities that have advanced manufacturing technician or AMT programs to implement research-based effective outreach strategies. The collateral, tools, and strategies developed as a result of this project will also be made available nationally and leveraged through NAEP's current professional development activities being implemented across the nation. We are ready to provide these opportunities for you to learn and network with each other. We hope to enrich existing relationships and establish new ways to engage and recruit female students to educational programs aimed to build tomorrow's advanced manufacturing workforce. We've created a suite of tools that you can access on our learning management system. Our suite has 6 modules. The first will introduce you to the NAEP courses and help to frame their content through the lens of advanced manufacturing. Modules 2 through 4 are NAEP's courses that educators across the country are taking to improve equity in recruiting, instruction, and career coaching. The 5th module contains our 9 best practices, of which I'll be looking at 1 today. The 6th module is a discussion space where our participants can share information, resources, and materials. And again, today we'll dive into one of our 9 best practices and invite you to join our learning management system where you can access courses, resources, and a link to our YouTube channel. NAEP has scoured the research on attracting females to non-traditional careers and distilled that information into 9 key strategies. Included in each of these strategies are samples and suggestions of what to do and what not to do, and resources that you can use with students and their families. We have already reviewed the first 5 strategies in these table talks. Today we will explore number 6, designing interactive hands-on activities. As some of you may know who've listened to these table talks, before becoming an educator, I worked in manufacturing as the only woman engineer on the production floor at Hewlett-Packard here in Colorado Springs, Colorado. As an engineer and then as an engineering and physical distribution manager, I was constantly frustrated at the lack of female and candidates of color for our engineering and technician programs. So it's become my mission to work to increase the diversity of STEM, and in particular for this project, Advanced Manufacturing. In addition to being a senior program manager for NAEP, I also worked as the executive director for the Southern Colorado Girls STEM Initiative, where for 10 years we've been hosting up to 400 middle school girls at the University of Colorado, Colorado Springs, where students get real-world, hands-on activities facilitated by female role models. Also, before joining NAEP, I ran the programs for the Center for STEM Education at the University of Colorado, Colorado Springs. We had a longitudinal research program that studied what attracts and retains students in STEM. We utilized many of the techniques and activities that I'll be discussing today in our research. Our research showed that our students were 3 times as likely to choose a STEM career major going into college as the general population. So these things really work. Some of the strategies that we used are the same that were independently validated by NAEPS researchers. So when you're doing recruiting or outreach to students, keep these equitable instructional strategies in mind. First one is use diverse role models when doing your outreach. In academia, this is called vicarious experience. Research shows that role models can have a big impact on students' belief about what they can accomplish. When models are similar to students find it easier to envision themselves completing the task or working in the field successfully. Research also shows that certain characteristics make role models more effective, such as perceived similarity to the learner, credibility, enthusiasm, and competence through effort rather than innate ability. Be purposeful about the role models you use and try to include diverse role models that represent the diversity of the students. When doing group activity, intentionally select your teams. Teams with only one student from a marginalized ethnic, racial, or gender group can be isolating and create a negative experience for that student. Beyond considering social, academic, and behavioral aspects when creating student teams, try to keep at least 2 students from any one group together if possible. Also, when doing group activities, be sure to rotate your roles. Student roles within a team can be dictated by gender or racial stereotypes, such as having the women be the note taker. Allowing students to choose their roles initially provides them some level of comfort. However, requiring students to rotate roles is also important so that they learn new skills. Role rotation also keeps students from feeling limited by gender or racial norms. Whenever possible, have students self-select topics and/or do the work to uncover ideas and apply knowledge themselves, rather than receiving information from a presenter. This is what educators call open inquiry. The less structured and scripted the activity, the better. Open inquiry allows students to learn by failure. Growth mindset and persistence through difficulty combats learned helplessness and stereotype threat that inhibit females in pursuing STEM careers. So allow for frustration and encourage persistence. This process of active learning increases academic achievement, motivation, higher order thinking, and skill development, and is particularly powerful to engage historically underrepresented people in STEM. An example might be having students pick something from home or an electronic cycling bin to disassemble. Another equitable instructional strategy is the power of storytelling. While using a storytelling approach may take a little time, it's a powerful way to engage students, especially those from Native American, African, Latino, and Asian cultures, especially if they are part of the story. At the Center for STEM Education at the University of Colorado, we had an Air Force grant to study what attracted and retained students in STEM. We utilized scenario-based STEM camps as part of our programming. For example, we had a CSI, or what we called Chocolate Science Investigation Camp, that was based on industrial espionage. Someone was stealing chocolate recipes at a competing company. There was even a dog, a chocolate lab, that was poisoned in a chocolate lab. The students were given roles and at the end of camp had to present their case as to who they thought was guilty. As I mentioned earlier, our longitudinal research found that our students chose a STEM career at 3 times the national rate. Storytelling and immersive storytelling really works. Skills and content that are connected to real-world outcomes can motivate students to engage in learning Authentic learning contexts, such as the ones presented here, are especially effective for women who have historically been underrepresented in STEM. Whenever possible, make learning matter even more by tying it directly to your community. So when you first start talking to kids, think about, or have them think about, looking around and imagining something that is not manufactured. Can you think of something? It's kind of hard to think of something in our environment that is non-manufactured, that is not natural. So, for example, a dog is not manufactured, but perhaps they are bred to have certain characteristics, such as Labradoodles. So in a sense, that breeding might have some manufacturing. Or trees are not manufactured, but how we process them into lumber is. So let's think about something like this pen. What about, how is it manufactured? It has a little rubber sleeve that might be molded, this little rubber sleeve. It also has a barrel that is plastic, hard plastic, that again might be molded, or I don't know, maybe extruded. I don't think this one's extruded, but there's an inside which has a tube that might be extruded and filled with ink, with the pen head that's inserted into the tube. And then you have a spring that's probably formed using some sort of forming machine. And the bottom part, which has a button that is inserted into the end. Lots of things to talk about with students about things, how things are manufactured, simple things. And just getting a familiarity with different types of manufacturing is important. Let's take a look at what some of those steps might be. The basic processes of manufacturing systems are casting and molding, shearing and forming, separating and machining, conditioning, joining and assembly, and finishing. And with the new technology, additive manufacturing. If the products that you're creating start out as a liquid, chances are the manufacturer uses molding. One popular type of molding is casting, which involves heating plastic until it becomes liquid, then pouring it into a mold. Once the plastic cools, the mold is removed, giving you the desired shape. Shearing and forming. When dealing with sheet metal, shearing comes into play. Shearing uses cutting blades to make straight cuts into a piece of metal. Another metal shaping process is called forming, which uses compression or another type of stress to move materials into a desired shape. Although forming is often used with metal, it can also be used on other materials, including plastic. Separating and machining. It'd be difficult to make products like metal parts without the use of some sort of machine. Manufacturers use tools like saws, shears, rotating wheels to achieve the desired result. There are also tools that use heat to shape items, such as laser machines, which can cut a piece of metal using high energy light beam, and plasma torches to turn gas into plasma using electricity. Also, erosion machines apply a similar principle using water or electricity. And of course, computer numerical controlled machines introduce computer programming into the manufacturing mix. Conditioning, any process that changes the property of a material using heat, chemicals, or mechanical forces. And then of course, joining and assembly. You can only get so far with molds and machines. At some point, you need to be able to put multiple parts together to make one piece. Otherwise, all you can create is IKEA-like furniture that needs to be assembled part by part. Joining uses processes like welding and soldering to apply heat to combine materials. Pieces can also be joined using adhesive bonding or fasteners. And then finishing, like polishing or painting. Last on the list is 3D printing, or what's come to be known as additive manufacturing. This state-of-the-art manufacturing is revolutionary because it eliminates expensive tooling and molds, making the process of prototyping and testing really quick and cheap. It also can make lightweight honeycomb shapes by adding layer by layer that molds can't achieve. This is an advanced manufacturing technology that many of our students will be involved in producing. Here's a more complete list of manufacturing processes. So what other sort of hands-on activities can get students interested in manufacturing? Let's take items that we have around the house. Anything that students can disassemble can be a lesson in manufacturing, such as a hairdryer. How are the parts assembled? There's a Khan Academy video called What's Inside a Hairdryer that can be really helpful in prepping you to work with students on disassembling a hairdryer. We can look at old computers or printers, household items. Mechanical clocks are great to look at gears. Lamps and small appliances like toasters. The less structured scripted the activity, the better. Open inquiry allows students to learn. Let them take it apart. Let them figure it out. Let them learn by failure. You need to allow for and tolerate frustration in the classroom as you're working with students. So here's some more questions. In addition to how are the parts assembled, what function does each part play? Are the parts mechanical or electrical? Is the part designed for form, in other words, how it looks, or is it designed for function, how it works? How are each of the parts made? Are they mixed, cutted, shaped, all those manufacturing processes that we talked previously? You need to ask those questions about how they might be made. Do you think that they were made and or assembled by people or machines? What about it makes you think that it was made for low cost? Or do you think it was made for high quality? What about it makes you think that it was made to be reliable? And lastly, what is the environmental impact of this item or part? How might you change it to be less of an impact on the environment? Also, another hands-on activity is anything that activity that students can make. This can be a lesson in manufacturing. And again, I can't stress enough that do not depend on something that is too scripted or too cookbooky. Students learn best by what we call open inquiry. Allowing them to tinker and allowing them to learn through failure is the best way for them to really experience the hands-on activity that you're sharing with them. So real popular hands-on activities are things like build the tallest tower with spaghettis. So questions you might ask is, how was it manufactured? How might you make the process repeatable? What defines quality in your tower? Another activity that's really popular, we call it Eggstronaut. It's basically an egg drop activity where the students have to protect the egg and drop it from a high distance. So some questions about that is, to look at how a packaging engineer works. The packaging engineer would design something to protect that egg. How is it protected? Other standard STEM activities can be looked at from a manufacturing lens. So things like CD hovercraft or mousetrap vehicles or solar cars, all these car or racer activities can be dissected and looked at from a manufacturing standpoint. There is an Introduction to Manufacturing Teacher's Guide that I'll be referencing here shortly, and there's a really good couple of racer activities in there. And they look at how they're made, what parts go into it, is the assembly repeatable? And another really popular activity for students in school are robots. And one thing it's really important to discuss, and we find that this doesn't happen often enough, is how the majority of American robots are employed in manufacturing plants. And we need more and more people to design, program, and maintain these robots. This is a really important lesson to share with your students. As an industrial engineer, some of my favorite hands-on activities show what can be, what manufacturing assembly might be. So there's a Lego assembly line. If you go into the tryengineering.org/teacher/assembly line, the students assemble a product individually that meets a quality control criteria. They are required to design and construct an assembly line process to assemble a product as quickly and efficiently as possible, meeting the quality control criteria. Then they have to test and redesign the assembly line and compare the differences between assembling a product individually versus using an assembly line. So this is a really, really great activity that shows what industrial engineers do. There are several versions of this. There is, in our learning management system, there's one that uses greeting cards. There's also one that uses bricks made out of paper bags, but I like using Legos if you've got Legos. Another activity that we have done with students is this idea of kitchen chemistry. The students get to invent a mock applesauce. This activity we use every year at our Girls STEM event. The students are given the role of inventor or R&D, research and development. They have to develop the best tasting applesauce out of Ritz crackers, different sweeteners, citric acid, lemon juice, and spices. Then they have to document their recipe so it can be manufactured in large batches. So that's an activity that can be turned into a manufacturing example. An Introduction to Manufacturing Teacher's Guide through the manufacturinginstitute.org has a couple more hands-on activities. They also have a lot of worksheets and more information about different careers. You might also look at teachengineering.org or tryengineering.org. They have huge repository of engineering activities, such as building roller coasters, which can be turned into conveyor belts and assembly line. Again, make sure it's not too scripted. Other things that tie to manufacturing are things like some technology tools. We've used Autodesk's Tinkercad. This is a 3D mechanical design as well as a circuit design and simulation tool, and this is free. It allows students to develop spatial skills, lets them think about additive manufacturing and 3D printing, as well as circuit design and simulation. Another technology tool is code.org, as well as MIT App Inventor. These are tons of resources for kids to explore computers and technology, as well as the MIT App Inventor allows them to develop their own app. So think information of things, IoT, manufacturing's getting into that, and so all of these tech skills are really valuable for teaching manufacturing. There's some production line simulations online. One's called Big Pharma. It's kind of a gamification of manufacturing concepts, and so that's a fun game to have students do, although it does cost money. And last thing is there's a really great website called Instructables. It's invaluable for providing inspiration for hands-on activities, and it's really big in the maker community. Again, remember that open inquiry is best rather than scripted build instructions. Frustration will be higher, but encourage the students to persist and learn through their failure. Hands-on is best. There are some games that I mentioned. There's also some welding games that gives a sense of the activity. And it's important that safety is an issue, but at the university, we believed in giving middle schoolers soldering irons. They can learn about soldering and welding. And always look for ways to tie the activity to a job that exists in manufacturing. Design, like the kitchen chemistry, industrial engineering, like the assembly line or the conveyor belt roller coaster design, process engineering, that sort of thing. Always, real world hands-on is best. So any chance you can get to give students a chance to get their hands on what they'll actually be doing is the best way to expose them to a career in manufacturing. So for example, utilizing some sort of open house at your high school or community college where you can showcase the programs. The industrial tech programs, or such as a Project Lead the Way open house. It's really important to include hands-on learning, again, allowing students to try out the activities or try out the equipment. Research shows that previous success increases students' self-efficacy. It allows them to answer this question, can I do this? So if you really want them to really consider a career in advanced manufacturing, giving them an opportunity to master something using some sort of hands-on experience is best. A story that I want to use to just wrap up here is NAEP was involved with a high school in Roseburg, Oregon. And the Roseburg team decided to implement some specific strategies to address low participation of girls in their welding program. The first strategy was to purchase welding helmets, gloves, and jackets in smaller sizes, which seems like a no-brainer to me, but they didn't have them. Secondly, the school began a new what they called freshman cruise class, in which all first-year students rotated through each of the school's CTE programs over a 2-week period. During the welding rotation, the instructor intentionally had the girls in the class demonstrate various welding techniques. The third, the school highlighted the welding program and its female students in a community open house. And the results of doing those 4 things, they went from 4 females in their welding classes in 2015 to 38 in the spring of 16 and 33 in the spring of 17, and it's gone up since then. So some really great results out of doing these sort of activities. So thank you for your time today, listening to me talk about hands-on experiences. This is my contact information if you have any questions about that. And just a reminder that as part of this program, we have a learning management system that you can access once you get signed up through our system, and it gives you lots of things to think about and some online courses as well as other resources. And again, just this project will make you better at your job and increase your professional network. It'll allow you to increase your knowledge about STEM equity and how to attract more females to those educational programs that lead to advanced manufacturing careers. Our courses and resources position you to be more efficient and effective with your recruiting practices. Through an expanded network of professionals engaged in similar work, you'll be part of a broader conversation on STEM equity and have access to samples and best practices. And most importantly, your engagement in this project will lead to increased participation of females, which is good for them, good for your organization, and good for the future of American advanced manufacturing. Thank you again for your time today, and I hope you have a great afternoon.